Dear student, this is about the overview of X-rays. In this chapter, I'll explain what are the important points. That is, I'll summarize X-rays. This is about the production of X-rays using Polish tube. Suppose the question is says that explain production of X-rays or explain production of X-rays using Polish tube. Dear student, first draw this Polish tube, then explain tension battery, purpose of this focusing electrode C, then filament of this part, then what is the purpose of or application of this target, and then explain about the high voltage source in terms of numeric value, and then write theoretical part of production of X. And then also explain reassurance K alpha and K beta. That is the graphical behavior of intensity with respect to wavelength. Okay. This is about the production of X-ray using Polish tube for only production of X-ray. Draw minimum half page diagram and then write explanation of production of X-rays and also explain this graphical behavior of intensity with respect to wavelength. Next point is in origin of continuous X-ray spectra. First draw this diagram. Show the uh, kinetic energy initially is half mv square, and after this process that will uh, can write here half p square dash, and during this we will get the X-rays, that is the continuous spectra, and also explain the graphical pair of relative intensity with respect to wavelength. That is here by increasing energy, this graph peak point is shifts towards lower scale. This is about the continuous X-ray. Then properties of X-ray, like the shorter wavelength requires high voltage, capitalization skeleton defects, always travel in straight line and do not carry any electric charge, and capable of traveling in wind. Then in terms of applications in medical field, security area, then medicinal field, radiation therapy, authentic, we can check authenticity of different types of art pieces, different engineering application, applied application in industry, we can use in industry, then research and development, in astronomical form, astronomy we can use, criminal investigations, and in crystallography. These are the different applications. You can write in different fields also. Then numerical problems. Find the shortest wavelength, that is lambda minimum. Shortest wavelength in lambda minimum. That is here. Formula for lambda minimum is equal to 1.24 into 10 raised to minus 6 upon capital. Okay. And therefore, from this example, we have potential, exciting potential is about 50,000 volts. We can write 50 into 10 raised to 3 volts. This is the standard formula. Dear student, directly state this formula. Lambda minimum equal to 1.24 into 10 raised to minus 6 upon V. Voltmeter upon V. V will get cancelled and you will get lambda min in terms of meter. Then here numeric term for V is about 50,000. We will put in equation number 1. Therefore, equation number 1 can be written as 1.2 into 10 raised to minus 6 upon 50 into 10 raised to 3. This is power, positive power 3. We can write here, this is minus 6, minus 3, this positive 3 will become minus 3, and 1 upon 2 upon 50. And 1 upon 2 upon 50 is about 0.0248. -6 we can write 10 raised to -9. Therefore 10 raised to -9 is nanometer. Therefore lambda minimum equal to 0.0248 nanometer. Okay. If you want to find out the shortest wavelength, therefore always use this formula. That is lambda minimum equal to 1.24 into 10 raised to -6, and from the knowledge of accelerating potential we can find out the lambda. Okay. Next example is find potential. We can use same formula, that is lambda minimum equal to 1.24 into 10 raised to -6 upon t. Therefore, rearranging this equation, we can write V equal to 1.24 into 10 raised to -6 upon lambda minimum. We have lambda minimum equal to 0.01 and from here we can write like this: 0.01 into 10 raised to -10 meter. We can put in this equation. After subtracting the value lambda minimum, B equal to this 1.20 into 10 raised to -6 upon lambda minimum. Lambda minimum is equal to 0.01 and from here 0.01 into 10 raised to -3. Therefore, 1.24 upon 0.1 into 10 raised to -6, this -10 becomes +10. And therefore, 124 into 10 raised to -6 plus 10 is equal to 10 raised to +2. That is in two. Next is Compton effect. For Compton effect, first draw this diagram and then write explanation. Also, first question is draw experimental setup of Compton effect, then draw this diagram, show source of monochromatic color with single wavelength or frequency, show polarimeters and X-ray spectrometry. So this is detailed angle of spectrum. Then also show this for 0 you will get only one peak, 0 degree scattering angle. After increasing scattering angle like from 0, 45, 90 and 135, there will be the greater the scattering angle, you will get the greater the wavelength as compared to scattering. So then for this time, then this is the comparison between photoelectric effect. This is the photon with energy hν, and this is the electron. Compton scattering, this is incident photon with energy hν, and you will get the scattered electron as well as new photon with frequency nu dash. In case of pair production, you will get two. One is positive and one is another is negative. This is about the comparison of photoelectric effect, Compton scattering, and pair production. Then for explanation of gravitational redshift, draw this diagram and see carefully. Here, this is your lower wavelength in maximum frequency, and away from this part, you will get the greater wavelength as compared to initial. Then for black holes, first draw this diagram, draw this part, explain what is the meaning of singularity and event origin, and state directly the formula for short-shaped radius, that is 2gm from system. Dear student, thank you so much and all the best. Thank you, student, and all the best for your efforts.